Okay, so first I'm going to review quadratics, but I'm going to teach it like you don't know anything, which for some of you is about right. Okay, so that's okay. Here we go. Quadratics. Now, quad makes you think 4, which is very tricky because it's not 4. It's actually a 2. But quadratics is this function, y equals x squared. What does the shape of that look like? A parabola. That's exactly what it is. Okay? So, when you learn this, you learn that this is a parabola. But now I want to tie it back into what we've been doing. Shifting things around. Stretching, compressing, reflecting. Could we have thought about parabolas in the same way? Oh yeah. Now this one is the parent graph, which means there's no shifts. It hasn't been moved left, right, up, down. It hasn't been reflected. It hasn't been stretched. It hasn't been compressed. So where would the starting point for a function that hasn't been moved? That's right. It's at the origin. It's going to start out at 0, 0. 0, 0. Now, this is how I want you to think about all functions that are in transformational form. I don't want you to memorize stuff, because when we memorize, we've got it for about maybe 3 weeks max, and then it's gone forever. I want you to understand, when we look at this function, x is being squared. So this function is a squaring function. It squares stuff. So when we're thinking about moving from this translation point, we square. What is 1 squared? 1. What is 2 squared? 4. What is negative 1 squared? 1. What is negative 2 squared? 4. And that is our function. That is our function. It makes a beautiful parabola whether or not I can draw one. Okay? And if we understand that one little concept that we're squaring, we got every parabola. Because we already know how to move things around. Okay? Let's look at this second example right here. Example number 2. Where do you shift the translation point on this quadratic? Where does it go to?
It goes right to right and down.
Right 2 and
Down 3.
down 3. So I'm starting at the point 2, negative 3.
Okay, wait.
Okay? Now, that's the first thing I do when I'm graphing functions that are in transformational form. The next thing I do is I look right here. I look at what's happening to the x. In this equation, the x is being squared. This tells me how I move from that translation point. These are the moves from that translation point where I just moved to start. So I square the moves. This is another quadratic, so we're going to square. So all you do in your head, you go 1 squared, 1. 2 squared, 4. Negative 1 squared, 1. Negative 2 squared, 4. Done. There's my beautiful quadratic. Okay? All right. Let's take a look at that next quadratic there. Y equals negative x plus 1 squared plus 4. Where does this function start? Where do I shift the translation point to? Negative 1, positive 4. The opposite of what's with your x, what's added to the end stays the same. Negative 1, positive 4. Boom. Now, every time I look, what's going on with my x? Oh, this one's being squared. So I square. 1 squared, 1. 2 squared, 4. But this has some down front. What does the negative out in front do to a function? It flips it down, doesn't it? So instead of going over 1 and up 1, I'm going to go over 1 and down 1. Instead of over 2 and up 4, I'm going to go over 2 and down 4. So when we're doing transformations of functions, Now, these can actually be called in vertex form because when we shift, this is the vertex of that function. We had a vertex with quadratics. We also had vertex with the absolute value we just finished, right? All right, so here's an absolute value. Where do I start on this function? Where does it move to?
3, 1.
3, 1. Okay, so I go over 3, I go up 1. Now, I look at the function. These bars, those bars tell me to take the absolute value. What is the absolute value of positive 1?
1.
1. What is the absolute value of negative 1? 1. What is the absolute value of positive 2? 2. And negative 2? 2. And 3 is 3. And negative 3 is 3. So this tells me what to do. I don't have to memorize anything. It tells me. It says take the absolute value. And you go, okay. All right, so when I draw it in, the absolute value are these beautiful straight rays that form that V. Now, do you see the nice little curve with the parabola?
Yep.
Parabola, curve, absolute value, straight. All right. So now that we know this, it makes today's a lot easier. When we look at this one, is there anything added to it? Is it shifted left, right, up, or down at all? No. So where do you think we'll start? At the origin. You are correct. Now, just like with the functions I've already studied, whenever I get a new one, I look right here. What is happening to the x? The x is being cubed. So how do you think I move from that point? I cube. What is positive 1 cubed? 1. But what is negative 1 cubed?
Negative 1.
Negative 1. Very good. Okay, so from this point, positive 2. Positive 2 cubed is 8. I'm off my graph. Negative 2 cubed is negative 8. And it creates this beautiful curve, which honestly, guys, we're already familiar with. Because remember when we first started graphing functions, and this was a 0. And we wrote it like this, and we said it's going to pass through the origin because that's like a 0, and it's going to pass through with an inflection because it's a odd power greater than 1. Isn't it cool how all this stuff ties back together? Does that look like an inflection? Yeah, it does. Okay, so anytime I get any function that's in this form, in a transformation form, where you can see how it shifts left or right, and you can see how it shifts up or down, and there's clearly something out in front or nothing that tells us about reflections and tells us about vertical stretches and compressions, we can graph them using these transformation rules. So the first thing you do is you find your translation point. So let's look at this one. Where is the translation point on this one? Very good. Right 2, up 4. I'm going to start at that point. 2, 4. And then, just like we do with every other function that's in this transformational form, we look at this. What's happening to the x? Okay? Oh, that is a negative 4.
Yeah.
That's why everybody had their hand up. Is y'all all right? Let me shift this real quick, right down. Woo! Fixed. Okay, so now we look at this. It's cubed. So, moves from this translation point get cubed. 1 cubed, 1. 2 cubed, 8. Negative 1 cubed, negative 1. And nothing else fits on my graph. So once you plot the points that fit on your graph, that's all you do. Then you make your little whoop, Yes, sir.
Can you scroll up a little bit to the formula?
I sure can. So I said out loud that if it's positive or negative, that tells you about the reflection, if any. If it's negative, there's a reflection. And if A is greater than 1, it's a stretch. If A is between 0 and 1, well, the absolute value of A, then it's a compression. All right. So let's look at this one. X is cubed. This 1/2 is going to be called that compression. There is nothing grouped with the X that's being cubed. There's nothing grouped in there. So this one actually doesn't shift right or left any. It just goes, what does this do? Up 1. So right or left 0, up 1. There's my translation point. Now this translation point for this function could also be called an inflection, because every place we translate to, that's where the inflection point of the graph is. All right, so now, just like every function, we look right here, we're cubing. We're cubing. All right, so 1 cubed is 1, 2 cubed is 8, -1 cubed is -1, -2 cubed is -8. And guys, if it helps you to write it down every time. If you can do that in your head, do it in your head. Okay? We got some of both in here, and that's fine. Now, this 1/2 is going to compress this function by making these up and down moves smaller. We got to multiply those up and down moves by the 1/2. So instead of going over 1 up 1, because of the 1/2, we just go over 1 up 1/2. Instead of 2, 8, because 2 cubed is 8, we're going to go 2, 4, because 1/2 of 8 is 4. 1, 2, 3, 4. Okay? And then same thing happens in the opposite direction, so it's -1, -1/2. -2, -4. Now, all 5 of those points fit on the graph. So when they do, plot them all. So your translation point and these 4 points are ideal. Most of the time it's not going to fit. Cubits can get really big really fast. Not as fast as exponential, but it still can. All right, so looks like I forgot to erase my work on the next one. We could just talk about it then. Let's talk about what happened here. Nah, let's do it. Yeah, it helps you to see things happen. All right. So when we look at this one, where does it translate to? Where does it start? The opposite of this, -3, 0. That's where I'm starting, -3, 0. Okay, and I'm cubing. I'm cubing. So 1 cubed is 1, but there's -2 right here. So instead of going up 1, I'm going down 2, because 1 times -2 takes it down 2. 2 cubed is 8. 8 times -2, you're right, is -16. Does not even come close to fitting on my graph. It would be way down here somewhere. All right, but let's go ahead and do the other. -1 is -1, but when I multiply -1 by -2, I get +2. So let me show you what just happened. We said 1 was 1, but then we had to multiply by -2. So we went right 1, down 2. And then we said 2 cubed is 8, but then we multiplied by -2 and it went way off the graph. 2, -16, nowhere near. And then we said -1 cubed is -1, and when I multiply that by -2, I go up 2. And then -2, -8, when I multiply that by -2, still isn't going to fit on the graph. That's +16. So I have a very stretched, and it's also reflected. Now, let's tie this back into some stuff we already knew. You already knew where this would cross the x-axis from our first unit. You know what the zero of that function is, so you knew where it would cross the x-axis. You knew there would be an inflection point right there, because that factor is raised to an odd power greater than 1. You know about end behavior. Normal is fall to the left, rise to the right, but this has a negative in front. So what's it going to do? The opposite. So you really could have graphed this one walking through the door. You knew it would have a squiggle, but now you know more points on there. So we're just adding a little bit to what we already knew. Now, anytime we have a negative out in front of our functions, those negatives do cause reflection over the x-axis. So it's going to change those up and downs to the opposite every time. All right, now, the cool thing, this is the coolest thing to me about the cubic. Domain and range are both negative infinity to positive infinity. There are no restrictions on those. So that makes it kind of easy. You don't have to worry about finding max and mins. There's not one on these. The whole function, when I just do a transformation of the parent graph, it's either increasing or decreasing. Do you see how this one is completely decreasing from negative infinity to positive infinity? Yet all of these were completely increasing, going up from left to right. Okay, so I'm going to give you some practice with cubics today. The front page, just like what we did. The back page asks you to think about transformations in general. If I make up this strange looking bird function, like wings of a bird, that's how I always drew one when I was in elementary school. If we shift it around, what would it look like? So this is in general terms. So this is specific to the cubic on the front, general on the back. Okay? All right, that's it. That's all we got.